All right, so this is the number 1 in 5.7. So if you look at this, you can label A as 3 and U as X, and this is going to be the inverse sign. I'm sorry, the inverse, that's right, the inverse sign. So the inverse sign I went over was du over a squared minus u squared square root, and that's the inverse sign of u over a plus c. So if a is 3 in this case, since 3 squared is 9, and u is x in this case, and 5 is just a constant, so our antiderivative is going to be 5 inverse sine of x over 3 plus c. And that's it. Okay. So I believe the next one was number 4. Number 4, the integral of 4 over 1 plus 9x squared dx. Well, this one looks most similar to the arctan. And the arctan was du over a squared plus u squared. And that gave arctangent of u over a plus c. So in this case, a is going to be 1 and u is going to be 3x. And the 4 again is just going to be a constant. So we're going to have, all right, we actually have to do a u substitution. We're going to make u 3x. So we're going to have 4 over 1 plus u squared. U is 3x, so du is 3 dx. Divide that 3 over, so we're going to have du over 3. So we're going to have 4/3 1 over 1 plus u squared du. And now we're going to do our inverse tangent of u over a. A is 1, so I'm just going to go ahead and put u back in and put 3x plus c. And this is our answer for number 4. Okay, so number 5 is the integral of 1 over x square root of 4x squared minus 1 dx. Now this one most closely resembles the arcsecant, which was du over u squared to u squared minus a squared, 1 over a, inverse secant of u over a plus c. So what we're going to do here is we're going to make a u substitution of 2x, because we're going to put this together as 2x all squared. So u is 2x, du is going to be 2 dx. We're going to divide that by 2. So then we're going to have the integral of 1 over, now u is 2x, so x is going to be u over 2. So I'm going to put that right there. So u over 2 square root of u squared minus 1 du over 2. Okay, well, this 2 is going to come up to the top here and cancel out with this 2. So I'm going to end up with 1 over u root u squared minus 1 du, which is exactly what we have here with a being 1. So we're going to have 1 over 1, which is just 1, inverse secant of u over 1 plus c. Now in the book they have an absolute value here, so I'll put the absolute value. Inverse secant, the absolute value of u was 2x, so 2x plus c. And that will be our answer for number 5. Okay, finally we have number 10. And number 10 was the integral of t over t to the 4th plus 16 dt. Now, to me, there's no square root, so I'm thinking it's probably going to be an arctangent. The problem is we have a t to the 4th, so I'm going to make this. It's going to be an interesting little u substitution. t squared squared plus 4 squared dt. Now it should look a lot like the inverse tangent if you looked at the inverse tangent integral. This time we're going to make a u substitution of t squared. So du is 2t dt. Divide the 2t over and put this right there. And we're going to have the integral of t over u squared plus 4 squared, and the dt is du over 2t. And the t is going to cancel. 1/2 1 over u squared plus 4 squared. Now this definitely looks like the arctangent. So I'm going to have 1/2 times the antiderivative, which is going to be 1 over 4 arctan of u over 4 plus c. Our last step here is to put our u back. We're going to have 1/8 inverse tangent. Our u was t squared plus c. All right, so those are 4 problems on the inverse trig function integration. Okay.